to find the output impedance of an unknown device, connect the device to power, connect a test signal Vs to the input, and then we're going to measure the voltage at the output, and we're going to call this the output voltage with no load connected. Now, although we're measuring this voltage physically outside the device, it is in effect the voltage inside the device, V out no load. Why? In this case, the output impedance has no effect because there's no current flowing through it. And if there's no current through an output impedance, or any impedance, then there is no voltage drop across that impedance. And so the voltage we measure at the output is the same as the voltage, hypothetically, inside the circuit before the output impedance, even though that's not really a physical location. Next, we're going to connect an output impedance, a test resistance to our circuit. We'll call it our L for a load, and we're going to remeasure the voltage at the same point, except this time we're going to measure the output voltage with a load connected. And provided we've chosen RL so that it is about within the same order of magnitude as what we think Z out might be, provided that's true, then we're going to see actually quite a difference between the output voltages with and without a load. Once we have these output voltages, we're able to calculate a value for the output impedance Z out. And we're going to do that by first considering what is the current flowing through the load resistor. That is going to be V out with a load divided by RL. If we have that current flowing through RL, it must also be flowing through Z out. And so we can write an equivalent equation that takes in the voltage drop across Z out, which is V out no load divided by V out with a load. Divide that all by Z out, and we get the same current. And now we've got an equation, it's got Z out in it. We can rearrange, we'll make Z out the subject, and that's going to be V out no load minus V out with a load divided by V out with a load, all multiplied by RL. So there we go. Provided we know the value of RL and we've measured the output voltage with a load and without a load, we will be able to calculate what the output impedance is.